Why does adding a second battery make your light bulb brighter? And how do we quantify this brightness in terms of voltage, current, and resistance? This is Ohm's law. So here's the core idea. Ohm's law, which is V equals I R, simply relates current, voltage, and resistance. It tells us that if you increase the voltage, the resistance stays the same, current goes up. If you increase resistance, current goes down. That is the entire law, but it explains literally everything in a circuit. Here's a microscopic view. Electrons through a wire move like people running down a hallway. Voltage, which is V, is how hard they're being pushed. Current is how many people are flowing past you per second. Resistance is how narrow or how rough the hallway is. So if you double the voltage, you push more people faster. If you double the resistance, fewer people can squeeze through. Here's how you're going to use the equation. You can rearrange it very easily because there's only 3 variables. So you can isolate each part for these 2 variations. And by the way, all of the equations for this topic is on the free cheat sheet in the description. So you can predict how much current will flow. You can also calculate how much resistance a device has, which I'll explain soon. And you can analyze how circuits will behave in real time. This is a quick example problem. You have an LED light that looks like this. And from a 3 voltage power supply, this LED is sucking up 200 milliamps of current. What is the resistance of this? Look at Ohm's law, V equals IR. We can isolate resistance and use this version of the formula. Voltage divided by current giving us R. So the voltage is 3. And I, we have to convert it into amps. So 200 milliamps is 0.2 normal amps. 15 ohms. This is how we represent resistance in ohms. But guess who it's named after? It's named after Ohm, guy who made Ohm's law. So we have 15 ohms of resistance. What if the power supply drops from 3 to 2.4 V? What happens to the current? The current is given with I equals V over R, which gives us 2.4 V divided by the resistance 15 ohms, which is 0.16 amps. This LED is going to dim. It's going to be less bright because there's less current flowing through. And what resistance is how much your material opposes the flow of electric current. Here's some clarifications. Current flows through a device. Voltage is applied across a device. And current, it doesn't get used up. It's what flows in and what flows out. Current is not a vector. Even though it has a direction, it's not a vector. In real life, resistors spell like this, and they look something like this, super small, like the size of your fingernail. They control current, and they're used in every single electronic device. Resistors are used to do things like divide voltages, pull signals from low to high, protect your LEDs from getting too much current and blowing up. Real life resistors are identified with their color codes, which tells you how strong they are, how much they resist current. Here's a conceptual example. If a current flows from point A and it enters a resistor before reaching point B, with this being the direction of the current, what have I drawn here? We have point A and point B and currents flowing across through a resistor. And you're going to see these type of diagrams very often in electricity. If A is at a higher potential and B is at a lower potential, and current doesn't change across the resistor, but voltage drops across it, this is called a voltage drop. And this voltage drop is how we track energy being used. Here's a quick recap of the most important things we talked about. Ohm's law is V equals IR, and it predicts how current behaves in every real circuit. Resistance limits current, so more resistance, less current. Voltage drives current, so more voltage equals more current. And you use this every single time you solve a circuit problem.